I would like to provide this information as a reference to give you an idea of the different types of effect sizes that are out there and which ones are appropriate to report for different kinds of tests and questions that we're asking. So as per Cohen's recommendation, as previously discussed, up top is that table that gives his guidelines for small, medium, and large effect size. Again, this is not an exact science, but it is great in our field because you can just always cite him. He's such an authority that nobody will probably question it unless you get maybe somebody will eventually question it, but for now I just really haven't heard of anybody questioning Cohen's guidelines for these effect sizes. So you can pretty much use these as just a reference point. So I just want to explain to you at the bottom portion of this slide the different types of effect sizes that are out there. The first one is Cohen's D. It's just that small d there, and typically this is for t-tests. So you can calculate this. Let me try to find a resource and put it at the bottom of the slide in the notes. There are several calculators out there on the web that are easy and convenient for calculating Cohen's D. I don't believe you can get it from SPSS, but you can get it from other sites, and what that does is it gives you an effect size for difference in means. So if you had an intervention group and a control group, you could report Cohen's, you'd report, of course, the t-test as well and the significance of that, but then to get the effect size, that's something different. That's the size of the difference and an index of how your treatment moved the dial on the outcome. So you would report Cohen's D for that. And that, again, is not available in SPSS, but I think you can get it from another source. So I'll put that in the bottom of the slide, like the website that you can go to. So typically it will have you enter your T value and the group sizes and some other things, and then it will spit out an answer for you for that. So again, Cohen's D, it's the difference between two groups' means, like an intervention group and a control group, in standard deviation terms, and so that might be helpful for IO students too. When you're reporting the effect of an intervention in an org, you may be asked for that effect size index. The R squared is probably the easiest to think about. It's just, you know, like a bivariate case, two variables correlating one variable with another. Like in a correlation table, for example, you have all those R's displayed, and if you square any one of those, that gives you the proportion of variance explained in one variable by the other. And so if you had a 0.20, you would square that and you get 0.04, and that would be 4% of the variability is accounted for in one variable by the other. So that's super easy. You don't need a special calculator to be able to just square it. It's really nice. Now for Anova and regression, there are a few different effect sizes that you can report. For Anova, remember you have the eta squared and the omega squared. The omega squared is just a little bit tweaked eta squared, really. It's more conservative, and it puts a little bit of a penalty for using a lot of predictors. We'll find out later that using too many predictors can artificially inflate your effect size, and so we want to correct for that, and that's when you'd use omega squared. The big R squared is for regression, and that's just the proportion of variance accounted for in a DV by an optimally weighted set of predictors, which we will talk about later in this class. So just a quick preview. But so you have two R squared, a little r squared, and a capitalized R squared. And the big R squared is for when you have two or more predictors in your model. And the little r squared is just for the bivariate case. Finally, for regression, we also have these F2 effect sizes, and these are used in G-Power. I'm not going to talk about them much in this class, but really they just depict the proportion of variance explained by a given predictor, and you divide that by the total variance that's unexplained by the model. And so that's another index for an effect size for regression. So those are the primary types, and I'm sure there are others, but in this class we will be working with the R squares and maybe just in passing mention an f-square, but overall it's going to be, for the most part, it will just be those r-squared. So focus on those, but I just wanted to give you the big picture, zooming out on all these different things that we have, different choices that we do have.